If you have any questions, please use the Q&A box, and I'll pose those to the panel, or we will answer it in the box itself. We've got quite a busy schedule for the next 2 hours, so I'm just going to hand you straight over to Andreas Netz from Vinnova.
Hi, ladies and gentlemen. Welcome to this information webinar for the second bilateral call between Sweden and the United Kingdom. My name is Andreas Netz, and I am head of department focusing on transportation and sustainable cities at Vinnova, Sweden's innovation agency. We are all experiencing difficult times, and large parts of society has never changed like now. It has impacted all sectors, but in view of the transportation industry and aerospace, the overnight standstill is unprecedented. Air travel in Sweden is down 97% during April. Given the current pandemic circumstances, we had to change the 2 planned information meeting events at the British Embassy in Stockholm and the Swedish Embassy in London to this webinar meeting. However, we are happy to see the large interest for this event with over 100 attendees. It is impressive how fast the world has adopted the new digital way of life. And given this situation, research and innovation is more important than ever in order to achieve sustainable mobility, societies, and growth, especially post-corona. And we are happy to launch this second UK-Sweden call. It seems as if both the UK and Sweden have developed their aeronautical strategies in parallel and independently came to the similar conclusion regarding cooperation. To stay competitive within aeronautics, you must collaborate with the best nations to reach excellence in research, innovation, and engineering. This is a unique opportunity to leverage the strengths of both the UK and Swedish aerospace sectors for future growth as the air transport sector transitions to a more sustainable future. And we hope that this call will be successful, although there are unusual circumstances in the world right now. Again, welcome, and I will now hand over to Mrs. Ambassador Judith Goff, the British Ambassador to Sweden.
Thank you very much. And for those of you who have not yet met me, I am the newly arrived British Ambassador in Sweden. I arrived here and took up my post last autumn. And I must apologise that we are not hosting you in my residence today as we had first intended. And indeed it was, as has just been mentioned, always intended that we would have a dual approach with the Swedish Embassy in London and us here in Stockholm jointly hosting something for you all. But obviously, times have changed and we are in slightly different circumstances. So it's a real pleasure to see that there are so many participants online today. And if my colleagues in the Swedish Embassy are in London are online today, hello to you in particular. I'm very pleased that we are able to be involved in this event. I won't take up too much of your time because the substance is before you. I am not an aeronautical or aerospace expert, but I think there are just a couple of points that I would like to stress. First of all, there is real and genuine collaboration between Sweden and the UK in aerospace technology. I think both nations have a proud and long history of cutting-edge technology and innovation, and that is something that both our countries, and particularly the British government, and I'm sure the Swedish government too, want to see continue. We recognise the excellence here in Sweden, and we recognise the value of that partnership and of that joint work and collaboration. So I think this is a really, really important initiative. It's its second time of running, whereby industry, academia and governments in both Sweden and the UK come together to launch this call for aerospace R&D projects between our two nations. And I think, as has been already mentioned, never has there been so much, I think, of a challenge for the aerospace industry at the moment, particularly for commercial airlines, who I think when we emerge from this period of enforced isolation or quarantine is going to find it is having to respond to quite a different market and different market demands. And the way through that has surely got to be innovation and collaboration. My embassy, for those of you who don't know my team, and thank you for them for helping with setting up this event today, stands ready to support anybody who is engaged in this industry. We have a very good and expert DIT section. We also have a science and innovation team as well. So please do draw on my embassy team if you would like assistance in any way, shape or form going forwards. So really, it's my job just to open proceedings today to thank you all for participating and not to get too much between you and the experts and the information that follows. But thank you very much in particular to the UK Aerospace Technology Institute and also to Vinnova as well as Innovate UK and BASE. Thank you very much. And I think I'm handing over, who am I handing over to now? Andreas, I think.
Yeah, you're handing over to me again. Thank you so much.
Thank you very much.
Thank you. I mean, you should really hand over to Carl Rosén, the Director General from Ministry of Enterprise and Innovation in Sweden, but unfortunately he can't join us today now in this digital world. So I will read up a statement that he has written. I am happy that we can launch the upcoming call with this web-based event in the difficult times we now are facing. Originally this was planned as an event at the British Embassy in Stockholm, but now I attend through a written statement due to technical reasons. We have already seen the first bilateral UK-Sweden call, engaged several SMEs and new companies joining the larger companies, institutes and academia in a very inspiring program. To judge from the interest for the second call, we will be able to even further strengthen the ties between our countries in aeronautics and therefore, in the longer term, also contribute to societal needs such as cleaner transportation, increased mobility and security for citizens. The worldwide competition in our aeronautics is sharp, and even though the post-corona market has an expected growth of 5% yearly, one has to be on the forefront in research, technical development, demonstrations and production, which is the prime focus of this call. Sweden and UK is now, with this second call, developing the long-term relationship for growth in terms of reindustrialization and export. At the same time, other sectors is developing cooperation, also military aeronautics, so we foresee a bright future for this cooperation. Finally, I would like to thank all individuals within ATI, Innovar, Innovate UK, Vinnova, and both our embassies in making this call happen. I end by wishing you all a successful continued cooperation.
That's great. Thank you very much for that. Right, so we'll move straight on to the introduction to the competition, and I'll hand over to Scott Pendry to kick things off from the Aerospace Technology Institute.
Thanks very much, Michelle, and good afternoon, everyone. Thank you for joining today's call. As many of you will know, the ATI was created in 2013 by the UK government and commercial aerospace sector, and we have two fundamental areas of work. The first is to set the strategy for UK civil aerospace R&T, and the second is to manage a portfolio of projects that will ultimately realise that strategy. Next slide, please, Natasha. The programme is now in its 5th year, and as you can see from the slide, over 300 projects are on contract, worth a total value of 2.6 billion. We've made a lot of progress during this time, particularly by expanding support to smaller companies through things like the NATEP scheme, introducing an accelerator program with Boeing, and expanding our international collaboration. But today's webinar is, of course, taking place, as we've heard, under unique and very challenging circumstances. Before talking about the UK-Sweden call itself, I wanted to confirm that the ATI program continues to run as scheduled, and the Institute remains very much open for businesses and open to companies and organisations seeking to engage with us to discuss potential applications. High-tech and innovative businesses in aerospace driving R&D are one of our great economic strengths and will help power our growth out of the coronavirus crisis. That's why we are so keen to maintain the momentum of the ATI programme. Next slide, please, Michelle. International collaboration, it's a core part of the ATI's remit. Simply put, no single nation has a monopoly on innovation, and working with other countries has a number of benefits. In addition to our EU-focused work, we've been working with individual countries, and over the last 4 years, we've built up a very good relationship with Innovair, Sweden's national strategic programme for aeronautics. During this period, we have met with representatives from the UK and Swedish industry, and through roundtables and various meetings, areas for collaboration have been identified, industrial and academic capabilities have been shared, and our respective aerospace strategies have been compared. The logical next step was to run a bilateral funding call, and in 2018 we launched the first UK-Sweden joint call for proposals for aerospace R&D projects, resulting in 4 high-quality projects which are now underway. We've been working hard over the last 6 months or so to develop another funding call, and this year's call, which will open on the 27th of April, has been designed to foster R&D projects to advance both countries' pursuit of simply transformative technology in air transport. It's been a team effort, and really I'm very grateful to our partners in Innovate UK and the UK's business department, the 3 of us making up the ATI funding programme, as well as, of course, Innovair, Vinnova, and the huge support of the British Embassy in Stockholm. So for this funding call, we'd like to see more proposals being funded. While we are, of course, pleased with the projects that are now underway, we'd like this year's funding call to enable more projects. Applications must be guided by the respective aerospace strategies of the UK and Sweden, pictured here, and available. These strategies are available to download on the ATI and Innovair websites. Both of these strategies have been recently updated, so it's worth your while having a quick look at the websites to download the latest copies. So before handing over, and in conclusion, if we could just go to the next slide, I'd like to say that the ATI wants to fund even more ambitious technology programs, and international collaboration is key to this. As well as continuing to promote ongoing UK-EU technological collaboration, bespoke bilateral collaborations such as this are essential. We are here to support and develop those aspirations, so please do engage with the ATI via the channels described here, as we are very happy to help. So I'll now hand over to Justin, Alexis and Sana, who will explain in more detail the funding process and requirements.
Apologies, unmute difficulties there. So Scott, thank you very much for that introduction. I say I will be picking up with Sana and Alexis on this call. I think we've gone past the slide already. So there we go. So Sana will be picking up from behalf of Vinnova. Alexis will be picking up on behalf of the Innovate UK, and I will be presenting on behalf of the overall eligibility criteria of the competition. Now, quickly, just to touch on this, we are using the EUREKA Network to undertake this international collaboration because it forms the umbrella under which we can do this with partly the greatest ease. It's an intergovernmental network aimed at market-orientated R&D innovation projects. Composed of 41 member states, which are the individual 40 member states plus the European Union, plus a number of associated states, which are Canada, South Africa, and South Korea. And there are also a number of international cooperation states that are involved. I'll quickly move on. Here's just a very quick map, this very old map of this. At the moment, the UK is included as one of the member nations, and works with the European Union, but obviously we're in transition. However, that will not impact this call in any way, and it is likely the UK will remain a member of EUREKA moving forwards. In terms of the scope of this competition, we're looking for a strong market potential for the UK and Sweden. So it is being driven by benefit for both nations leading this call. Scott's already picked up on, and we will touch on a number of times, that participants must, in their undertakings, fit within their own national strategies. That is to say that Swedish companies who are involved should have their activities aligned to the Swedish strategy and the UK ones to the UK strategy. You don't have to match to both strategies simultaneously, because that would make life very difficult, although they are very similar. We are hoping for a very high demand from the initial information we're seeing, so we expect to be competitive. We will fund the highest quality applications, and we will reserve the right to apply a portfolio approach to this competition to ensure that we have a balanced portfolio across nations and technological areas, amongst other things. That's fully detailed in the call text, as is the financing. So compared to the last call, we have increased the funding available slightly. Here we are talking in euros, because this is framed in the under EUREKA, which is mainly European members. However, we have put an indicative chart to the other side to show what the approximate values are in both Swedish crowns and British pounds. It's worthwhile noting the figure quoted is for the total project size, is for the total grant and organisational contribution of the funded participants only, across UK and Sweden combined. That is those that will receive grant. We have a rough grant size associated with that, which is €860,000 per project. That is combined grant contribution from UK and Sweden. However, because we have slightly increased grant rates, as we will touch on later, for the academic partners, if you have any, it may be that you extend beyond that threshold slightly. We would say that if that is the case, we would suggest you get in contact with Innovate UK and Vinnova at least 10 working days before the competition closes to advise us. And also, if you do have unfunded partners, be they UK, Swedish, or from a third country, and by third country, we would recommend you stage those that are EUREKA members, associate members, or have international cooperation, because those are easier in terms of the application process. Then it's likely you may extend over that maximum total project value. Again, we would request that you get in contact with us in advance. The total volume of the call is expected to be in the circa €9.5 million region, and that's both industrial plus grant contribution. Grant funding approximately half of that, and we've broken it down then into the grant contribution of Sweden and UK, which are very similar, expressed here in crowns and pounds. It is worth noting that no one nation should represent more than 70% of the total eligible project costs. This is to ensure that we have proper cooperation between the nations. Turning to eligibility, again, we will reinforce we are expecting this to have an economic output in terms of commercial products, applications, or technology-based services. The proposals must include 2 businesses, one in Sweden, one in the UK, and they should be non-linked. And you may also include research institutions, universities, public sector, and other organisations as required. Plus, there are third countries, and a subcontract is also allowed under each nation. I will touch on that later. What we mean by linked businesses is those that have an ownership between them, a parent or child company relationship, a shared parent, i.e. they are organisations within a group of companies, or where they have one has a majority stakeholder in another, or a significant influence through, say, voting rights, etc. A very quick diagram to express this. Please ignore which way round the British and the Swedish flags go, because they're interchangeable ways. Say this is just to express this in forms of a diagram of the types of collaboration that we can't have and those we can have. We would expect there to be one of the businesses to be leading in terms of the overall project, be that UK or Sweden. However, we would also expect a business to be the national lead on the side that is not the leading nation per se, and I believe Alexis and Sana will touch and explain that a little bit more. We've touched on alignment with the R&D strategies of each nation. State aid rules do apply to this competition. We are looking for projects that are undertaking industrial research. We are not funding feasibility studies, experimental development or fundamental research, and all projects should fit under Article 25, Aid for Research and Development Projects. It is the responsibility of each organisation participating to ensure that it fits within the relevant definitions, and there is a link provided to the block exemption rule that everyone can look at. We are anticipating that the work is carried out within the national boundaries for which grant funding is received, so mainly within UK and Sweden, partly for the majority because we are expecting the benefits for UK and Sweden out of this, not other ones. However, we do note there is often some need of subcontract due to unique facilities that may not be available in those individual nations, or it may not be practical to have some organisations as partners. This should not exceed 20% of the individual partner's total costs. I will reflect on this slightly and advance this very quickly. Projects should be no less than 12 months long and no longer than 36 months, so 1 year to 3 years. The start dates here and finish dates were based on the original competition dates. Ideally, we would like projects to be start ready by the 1st of September, although we appreciate this tight. This was based on national funding restrictions, and as was referred to earlier in the presentations, there has been an impact due to COVID-19, with Innovate UK being very much at the forefront of some of the UK government efforts, which has impacted the start date or the opening date of this call. We do have mitigation in place, and should you be awarded funding, we will discuss this with you at that point in time. It's important to note that if you are awarded funding, all partners must start their project on the same date, and we do require a consortium agreement between all the partners that is funded and unfunded. That is required within the first project quarter from the start date. Let's say we've other organisations, other EUREKA member states may also participate. They will need to find their own funding, and the project must meet the basic eligibility criteria. We will not fund projects that work exclusively on non-civilian applications, so there must be a civilian application in there, and you will need to refer to your national strategies and funding rules in order to understand what the balance that means. If they are not in scope, so they do not fit the respective strategies, do not meet the national eligibility criteria. If you do not submit all the required documentation for the application, we cannot take them forwards. And again, you must include at least one UK registered business and one Swedish registered business. We would advise that if you are looking to put an application, that you speak to your respective strategic bodies, in the case of the UK, the ATI, or in the case of Sweden, Vinnova. So with that, I will hand over to Sana from Vinnova.
Do you hear me?
Yes.
You can hear me?
Yeah.
I just hope for that now. Good afternoon, everyone. My name is Sanna Edlund, Program Manager at Vinnova and responsible for the Swedish program for aeronautics. I will provide some information that concerns the Swedish organizations. In this call, the Swedish funding is provided by Innova, which is the Swedish National Strategic Program for Aeronautics, and is being funded by Vinnova and also by the Swedish Defence Force. In this call, Swedish organization can apply for a share up to 22.5 million Swedish crowns to develop aerospace technology in partnership with the UK companies. As Justin mentioned about the projects, they must demonstrate alignment with the Swedish aeronautical research and innovation agenda and have a strong market potential in Sweden. Next slide, please. Very short about the funding levels. In this call, businesses of any size can get grant funding for eligible project costs up to 50%. Academics and research organizations can get grant funding up to 100%. Note that the total grant requested by academy and research organizations may not exceed 30% of the total grant requested by the Swedish participants in the project. So for example, I just made an example here. If a Swedish consortium seeks 2 million Swedish crowns, academy and research organization can receive maximum 600,000 Swedish crowns in grant funding. Next, please. So, how to apply? The Swedish organizations submit their project application at Vinnova's website using this link here. Swedish participants can apply for grants according to Vinnova's general terms and conditions for grants, which are available at Vinnova's website. The following documents are submitted: the completed EUREKA project form and the integrated project delivery plan and milestone register, budget and signatures. The applicants are advised to follow the guidance provided in Annex A and B in the call text. And also make sure you submit all required documentation. If not, your application will be ineligible and Vinnova will not send it for assessment. Once again, the 1st of July, the deadline to submit the application is the 1st of July at 2 o'clock. Next slide, please. I know Justin also mentioned this, but before submission, the Swedish organization that are interested in submitting a project are recommended to contact Innover to discuss how the project is aligned with the National Aerospace Strategy Plan prior to submission. You can use this email on this slide. All other eligibility criteria queries should be directed to Vinnova. Next slide, please. So I would just say a few words about the assessment process. After the competition closes, the following process will take place. First, we will do an eligibility check will be carried out by Vinnova and Innovate UK. Thereafter, assessment will be managed by Sweden and UK for their respective nations, an independent assessment by Vinnova, and strategic assessment by Innover. Thereafter, consensus panel to be held between UK and Sweden to agree upon final funding decision. We will have a balanced portfolio approach based on framework. Funding award to successful projects will be announced by the end of August. And EUREKA labeling and endorsement in October 2020. Next, please. And this is just an overview of the application process I already mentioned, but just to be clear, download the documents. You have the link here on this slide. Complete all required documentation. Upload the documents at the latest the 1st of July at 2 o'clock at Vinnova's website. Assessment period, July, August. And finally, the funding decision in the end of August. Next, please. And just finally, for successful applications, prior to start, all Swedish participants, including an assigned Swedish coordinator, must fill in the form participants' approval and submit to Vinnova together with a start report. All projects shall have entered into consortium agreement no later than 3 months after the start date of the project when submitting the first status report. And that was all I had to say for now. So thank you. Hand over here to Alexis.
Thank you. Great. So for UK registered organisations, we're asking UK registered businesses to apply for a share of up to that £2.25 million. And once again, there's some overlap in what we've previously said. It's to develop aerospace technology in partnership with businesses from Sweden and organisations from other EUREKA nations. So organisations can be academics, research organisations, could involve charities if that's applicable. UK registered organisations must sign up to the Aerospace Technology Institute Framework Agreement, and that allows for data sharing with the Aerospace Technology Institute. And your project proposal must demonstrate alignment to the UK Aerospace R&D strategy, and there's a link to that in the slides, but it can also be found on the ATI website. Funding levels for the UK side. So businesses of any size can get grant funding for the eligible project costs of up to 50%. So eligible project costs, there is more information about what that means on the Innovate UK website under the general guidance for applicants. And UK registered research organisations in your consortium can share up to 30% of the UK total project grant. So for businesses, you can claim the eligible project costs. Your grant can be up to 50% of those costs. When you look at the total costs for the UK project grant, your UK registered research organisations can only take up to 30% of that. So that might take a while to for you to digest that and work out the figures, because obviously this is slightly different from what Sana showed you for the Swedish funding levels. So if your consortium does contain more than one UK registered research organisation, that maximum 30% will be shared between them. And each partner must carry out the majority of the funded work within the nation from which it receives funding. So for the UK, you're receiving funding from Innovate UK, therefore the work or the majority of the work should be completed within the UK. And this is a bit of a repeat, but the competition provides state aid funding under Article 25 of the General Block Exemption Regulations. And you can go and look that up, and it's your responsibility to make sure that your organisation is eligible to receive state aid. So unfortunately, Innovate UK cannot provide any additional guidance on whether your organisation is eligible to receive state aid. So your proposal, it must say how the intellectual property can be used and shared between the participants and nations. It must explain why the research is being conducted internationally. It must explain the benefit of participants from the two nations working together, how working internationally adds value, and how your project contributes to sustainability in aerospace. So this is quite a new area of focus. So we're not asking for a specific question on your project's contribution to sustainability in aerospace, but as you fill out the application form, these are the things you need to bear in mind, and these are the things that our assessors will be looking at as a holistic approach to your application. So for the UK side, it's also an online application process. So the UK lead applicant, and this can be the lead for the overall project. So if the nation claiming up to that 70% is the UK, then the lead for the whole project will be considered to be the UK. If the UK grant claiming partners are led by the Swedish nation, you can nominate one UK point of contact to be the lead, and that UK lead, is the person who goes onto the Innovation Funding Service, IFS, and they invite all of the other UK participants to that application. So the Innovation Funding Service, we want you to complete that EUREKA project application form, but on IFS, we are looking for your answers to the questions to be predominantly talking about the UK applicants. So for question 1, we're asking you to submit the completed EUREKA project application form. So that gives us an overview of your whole project. We're asking you to upload the integrated project delivery plan and milestone register. That will be available on IFS for you to download. And that, again, you should be working with your Swedish partner. So it should give us an overview of your whole application. Answer all the questions on the Innovation Funding Service. So for the UK side, our additional questions are around benefits, added value to the UK, and equality and diversity. For the benefits and added value, those questions are needed by our colleagues at the Department for Business, Energy and Industrial Strategy, because they will also review your application for value for money. Complete the finance section on IFS. So the finances, that is purely for the UK participants. And if you're the lead UK applicant, then you're ensuring that all UK participants have completed their finance information in the Innovation Funding Service before you click submit. So if you do not submit all the required documents, your application will be considered ineligible, and Innovate UK will not send it for assessment. We do obviously have avenues for applicant support in the UK. There's the Aerospace Technology Institute. There is the Innovate UK customer support service, and their telephone number and email address are there, and they can advise on both the EUREKA application process and the questions in the Innovation Funding Service. There will also be an applicant briefing. So as we've said, the call actually opens on the 27th of April. The applicant briefing will be the 7th of May, and details of how to sign up for that will be on the Innovation Funding Services portal. If you can't dial into that applicant briefing live, it will be recorded, and it will again be put up available, the link to that, on the Innovation Funding Service after the 7th of May. And just a reminder that the close date is the 1st of July. And as Sana said, that is 2 p.m. Central European time. So that means it's 1 p.m. British time. So please do not confuse that, UK applicants and Swedish applicants. So UK applicants need to submit by 1 p.m. UK time. So a bit about the assessment process. So after that competition does close, eligibility checks will be carried out by Vinnova and Innovate UK. The assessment will be managed by Sweden and UK for the respective nations. And for the UK side, there's an independent assessment by Innovate UK, and that's based on the EUREKA project assessment methodology. So that is another document. There's a link to it here. You can search for that on the EUREKA website. And so you have an overview of what our assessors are looking for in your application. There's a strategic assessment by the Aerospace Technology Institute. So advice again is contact the Aerospace Technology Institute to make sure that you do fit within the strategy. And they will, that information will form part of the funding decision. And the Department for Business, Energy and Industrial Strategy uses some of those extra questions, so the questions around benefits and added value to the UK, they use that for a value for money assessment on your application. After the UK and Swedish side have completed their assessments, there's a consensus panel held between UK and Sweden to agree the final funding decision. Again, we are expecting a high demand, so we will be funding the projects with the highest scores, but also looking at a balanced portfolio approach between countries, between technology areas. And the funding decision will get that to successful projects by the end of August. And the EUREKA labelling and endorsement takes place, we're hoping, in October of this year. So there's a little a picture of what the assessment process is. So your application comes in, it goes to the various Vinnova if you're for the Swedish side, Innovate UK for the UK side. There are parallel assessments, so Innova and the Aerospace Technology Institute are doing strategic assessments on both sides. We have an additional parallel review by the Department for Business, Energy and Industrial Strategy, and then we come together to make those decisions, and we report those to the EUREKA Secretariat. And then you are contracted through Vinnova or Innovate UK. So for successful applicants, for UK applicants, your project setup phase will happen also in IFS, so on the Innovation Funding Service, and all queries from our project finance teams will come to you through IFS. So everything's in one place for you. So the offer of funding is conditional and subject to the satisfactory completion of the finance review by Innovate UK and project document approval by your Innovate UK assigned monitoring officer. So upon satisfactory completion of those pre-start checks, Innovate UK will issue the grant offer letter, obviously, to the UK funded partners, and each of those funded UK partners must sign that grant offer letter. You should upload it back into IFS, and then Innovate UK can approve that, and then you can start your project. In addition, this has been said previously, all project participants must have entered into a consortium agreement no later than 3 months after the project start date, and we are expecting that both the Swedish side and the UK side will be starting on the same date. And Innovate UK will not make any payments to UK participants until all of these documents are complete. So that means that you need to have that consortium agreement in place within 3 months of the project start. Otherwise, when you put in a claim, we will not be able to process it. So again, here's another picture representation for those who like more graphic format. So download the documents. So for the UK side, that's the EUREKA project application form. That's our question 1 in IFS. It's the integrated project delivery plan and milestone register. That's question 2. Answer all the other questions on the Innovation Funding Service. Complete your documents, you upload them, and that is the 1st of July, 1300 hours, 1 p.m. UK time. So please, please, please do start in good time before the closing date. We have been running competitions through IFS for several years now, and we still always see this peak just before that deadline time. And obviously our customer support service has a limited number of phone lines. So if you're running into trouble just before that deadline, they may not be able to get to your call or your email. Review of the assessment process, we're expecting to take place in July and August. So for the UK side, there's the Innovate UK Independent Assessment, Aerospace Technology Institute Strategic Review, Department for Business, Energy and Industrial Strategy Value for Money. Then we have our UK-Sweden consensus meeting. We will send you the funding notifications, and then for the UK side, there's the extra finance checks, and the monitoring officer approval of your documents, and then we will issue your grant offer letter. So that's all from us.
Thank you, Alexis. So in terms of questions, we are running slightly over. We've got a few things to get through as well, industry presentations and then a series of pitch presentations. So it looks like some of them are already being addressed online. So I think what we'll do is we'll move on to the industry presentations and then perhaps ask Alexis, Scott and Justin to address some of the questions that are appearing in the Q&A, if you wouldn't mind, that'd be great. So next up is Gary Way, and he's from Rolls-Royce. Over to you, Gary.
Let's unmute myself. So can I be heard loud and clear?
You can.
Excellent. Okay, that's a good start. So thank you very much, and thank you for the opportunity to share some of our thinking and activities which might hopefully help stimulate some further discussions later on and after this important webinar today. So my name is Gary Way. I'm the head of EU and international R&T programs. And what I'd like to do, just very, very quickly, recognizing the time and the number of slides I've got, is just give an overview of Rolls-Royce for those who aren't familiar or for those who would like an update on that. A sense of where our R&T activities are going and heading, because again, that may help stimulate some potential connection points. And then just very briefly at the end to share a bit of our experience with the call in its first phase that took place last year, and then also just very quickly our thinking about what could be opportunities for this. So in terms of us as a company, we are one of the world's leading industrial technology companies. Primary purpose is really about getting the power that matters to connect people and protect society. And we do that through our businesses and through our strategy. Now, in terms of, do I have to say kindly to ask somebody to move the slides forwards, or can I do it myself? I think on that there. Right, okay, good. So in terms of our strategy, it's really looking into the new way of how our business is going to operate and how individuals, companies, nations, etc. operate, and really digitization and electrification are key to how we look at utilizing power in the future. So at one level, that is about our existing capabilities that we have over the years that we've worked across a whole range of power industries, but pushing even harder now in terms of electrification, looking at how we can reinvent how the business works in terms of digitalization across the entire life cycle. And within that, making sure that the business we've got is appropriately balanced and transformative in terms of the people that we deal with as customers, the people who work for us, etc. Because at the end of the day, that and our technology are core to our strategy. In terms of our business performance as a whole, things have got better. Clearly, life's going to be more interesting over the next 12, 24 months, etc. Interesting little point there in the bottom is in terms of our number of patents is considerable. So really, it goes to show that innovation is at the heart of our business to lay the long-term strategy out for the future, and a considerable amount of our research technology development money is spent towards sustainable type activities in terms of how the products operate, how they can operate more efficiently, how the customers can get more for their money. So a considerable amount of time and effort is spent on that R&T activity, which really underpins what I'll touch on briefly in a while. In terms of the businesses, they're built around the three core streams of civil, power systems and defence. From an aerospace R&T perspective, then clearly we're looking to a great degree at the civil side of things, but obviously there are spin-off opportunities into other aspects of our portfolio as well as we integrate our technology fields together. In terms of our focus in civil aerospace, then we've really got three principal areas that we are continuing to work on, which is in terms of continuing to evolve the gas turbine to get increasingly larger amounts of efficiency out of that by interesting methods on dealing with the thermodynamics, reducing weight, etc. And then as those products get to different sizes and shapes, then it continues to be a key point to improve the integration and between the airframe and engine, not just physical but functional. And as mentioned, continue to look and develop and push forward in terms of alternative technologies, in terms of electrification and other energy carriers, for example, hydrogen. And across all of those, hydrogen being a particular type of example, it's making sure that we collaborate on sustainable aviation fuels. And we've been working over certainly the past couple of years with more visibility with our fellow aerospace companies and with the fuel companies to try to begin to increase the coordination and the strategic thinking between all the relevant stakeholders on getting sustainable aviation fuels with more penetration into our products. In terms of some of the specific technologies that perhaps at one level underpin the kind of gas turbine activity, but also into things like hybridization and electrification, then you can see an overview on this slide. I'm not going to go through each individual one, but that is a sense of the range of things that we look at clearly from the highest level in terms of architecture, which really does fundamentally unlock some of the efficiency improvements and emissions reductions, into our manufacturing technologies, the materials which are really the foundation of that in terms of how they are used across the product range, and then the intelligent systems in terms of how those are designed and integrated together, and then how they operate within a sort of system of systems approach, ultimately in terms of delivering a better life cycle improvement overall and clearly a greater sustainability. So those things there are just thoughts which may again stimulate some of the thinking in terms of areas of interest for us. I've mentioned integration, a key point. Obviously, in terms of ultimately our products have to be integrated into a prime mover, in this case an aircraft. So there's a range of things that we've done there and continue to work on with airframers, research centres, etc., to continue to improve that, as I mentioned, either in terms of the functional performance, whether that's in things like noise, drag, etc., or physical characteristics as well. And just briefly touching on electrification and civil aerospace, whilst there's quite a lot of uncertainty as one begins to move up from the smaller passenger numbers, then it's something that we are looking at increasingly with a range of products that we are investigating from a technology perspective, and that is something that we need to continue to work on as the challenge in terms of decarbonisation is going to increase as time moves on, and the expectation of delivering real impactful technology into the marketplace is there. So again, electrification increasingly across the civil aerospace range is going to be key, whether it's 100% electric at the bottom end to more electric capability at the higher end. And then I've touched briefly on the fuels before. Again, what we're particularly keen to help stimulate is how to make sure those fuels are, all three of those things are shown there: suitable, sustainable and scalable, to make sure that that can be a genuine impact to the operation of aircraft in the future, as it says there, but with it being sustainable relative to all the other demands that occur within the environment, but getting that scaling to the right level to actually have that impact. So that's a very quick overview of the sort of technology strands that we are looking at and very closely working in conjunction with a whole range of partners across universities, funding agencies, both in the UK, within the European domain and other places as well. One particular example just to share from the last call that took place with Ascatron was a silicon carbide technologies for aerospace application that's 18 months long. It's got 5 participants and is looking there at novel transistor devices for use in aerospace. And the latest feedback I've got from my colleagues is that project is going well with good participation and collaboration and really importantly good insight to potential exploitation in the future as well. And finally, just bringing it back to a conclusion in terms of where we're interested in looking, whether it's across the UK or within Sweden, you know, the range of stakeholders, whether they're conceptually things like catapult centres, universities, SMEs or other industrial organisations, all key to us in terms of how we operate overall and therefore relevant to this potential call as well. Clearly in the current environment we've got to be really smart about how the financial contribution and the financial construct takes place with this call. But nonetheless, you can see there under the topic areas there's a whole range of things that of potential interest to us, maybe a little bit more focused than some of the previous slides, but it gives you a sense of the broad range of topics that are totally relevant to us in terms of delivering our strategy. And also, finally, we've got clearly a range of experience with working with some excellent Swedish organisations to date, and I'm sure going forward in the future as well, with our colleagues in GK and Chalmers and, as previously mentioned, Ascatron. So some really good experience there that we can lean on going forward. So hopefully I've given a quick trot through what we're interested in, where we're at, what we're looking to progress, and that there really is some interest in how can we use this, the benefits of this call to help facilitate some joint activity to really push aerospace technology forward. So thank you very much again for the opportunity, and look forward to seeing the later information in today's webinar. Thank you.
That's great. Thank you, Gary. All right. So Jenny, please. Jenny Gardner from Saab.
Yes, thank you so much. Many thanks for inviting Saab and myself to speak here today. It's really cool what we now can do with these web-based conference systems as a way to keep people both informed and safe at the same time. So my name is Jenny Gardner, and I'm the director of the Saab UK Innovation Hub. I've had the pleasure of being part of this bilateral funding journey before, and I'm very grateful that we as a company had the opportunity to be part of the first call in 2018. And now I'm looking forward for us to take this new challenge on. Today I will use about 10 minutes to talk about Saab as a company, specifically about some of the things we do in the UK, the links between the two countries, but perhaps most importantly, what type of bilateral research project is a company like Saab now looking for from this UK-Sweden aerospace calls? So next slide, please. So Saab was established in 1937, just before the Second World War. The aim for the company was twofold. It was to provide a strong defense capability in a very geopolitical unstable situation that Sweden found itself at the time, and it was to build aircraft basically from scratch. And that is what we still do today. We aim to keep people safe with our products and solutions, and we build aircraft, the Gripen, but we also do a lot more. Next page, please. Today we have customers all over the world. We have about 17,500 employees, approximately 3.5 billion pounds in turnover, and we build aircraft, but we also sell products in all the different domains, as we call them. We're a growing and profitable company. 2019, we had an organic growth of 6% and a margin of 8.3%. Next, please. So today, as I said, we work in many domains. We work in air, land, and naval. Our defense portfolio is quite multifaceted and contains everything from full platforms, systems, to even components. You see here some of our flagship products, not only the fighter jet Gripen, that you see to the very left corner there, but also the submarine A-26 to the right. We have combat system, land and air surveillance, and much, much more. Next, please. But we're also very active in the commercial domain, so not only the defense, but also in the commercial domain. We're a digital company, so we have many advanced control, command, and communication services and systems for the civil market and for the security sector. We still own and fly a portfolio of civilian aircraft, the Saab 340, for example, the 2000. We do MRO and we build aerostructures, just to mention a few of our activities in the civil sector. Next page, please. We believe that true collaboration leads to better solutions. So when it comes to research, we look at something called the triple helix model, which refers to, triple helix is really about the industry, government, and academia collaborating and working together. As this does not only generate really good results, but it also creates growth in the whole society. And that is also why we have a lot of different collaboration partners. As for example, we have an ample network of universities all over the world, and we work with many companies, small and large partners. Next slide, please. Talking a bit about what we do specifically in the UK, Saab has been in the UK for more than 40 years. We have about 300 direct employed staff. We also have a very strong suppliers base in the UK. We have almost 1,000 suppliers that help us supporting our global portfolio, so a very close link there. And we are delighted with this bilateral UK-Sweden Aerospace call. This is a good example of the two countries working together, sharing values and understanding of developments. A couple of examples of the like-mindedness from our perspective is the Sweden-UK program of defense cooperation that was signed in 2016. Sweden signing the Joint Expeditionary Force in JEF in 2017. And if you go to next page, please, because that is the most recent and brilliant example of collaboration now within the high-performing aeronautics field between the two countries, which of course is the MOU that was signed in 2019 between the Swedish and the UK government regarding cooperation on future combat air systems, the so-called FCAS. If we could go to next page, please. So with this like-mindedness and collaboration in mind, let me talk a bit about what we do on the innovation piece in the UK. And just first to say that innovation for Saab is much broader than just product and technologies, but really everything that goes into the business, also addressing environment, economic and social aspects. So let me especially mention how delighted we are to see the enhanced thinking around environmental impact also in the two countries' aerospace strategies. But Saab sees the UK as a very important market and had decided to invest in UK R&D. So in June 2019, we opened an innovation hub at Imperial College, White City campus in London. And the hub will manage initial seed investment of £3.5 million into Saab's research network and project. And this is expected to grow. So next page, please. And this particular kind of page I wanted to show because it shows a bit some of the resources that we have in the UK for bilateral work. So as I mentioned, we have the Innovation Hub at Imperial, which is a focal point for the Saab R&D in the UK, especially for our defense and sensor radar research. But I would like to highlight the collaboration we have with the Cranfield University, which is a very important partner for us, especially for the civil sector and our aeronautics portfolio. So I would like to talk a bit about the resources we have there. Firstly, we are a founding partner and a member of something called DARTEC, which is a Digital Aviation Research and Technology Center. You see it up to the very left there. There is a building under construction. It's going to look fabulous when it's done. At the moment, it's in construction, you can see, and it's quite a large building. It's going to be a lab of labs, you could say, a center to focus on the interconnectivity and the system integration when it comes to digital technologies in this particular field. So that's quite exciting. Then we also, secondly, opened in December 2018, the first digital air traffic control center in the UK, together with Cranfield. It's basically as a remote tower, but it gives it the opportunity to do research in many interesting aspects in connection to air traffic management. And then thirdly, and last but not least, Cranfield University has recently bought a Saab 340B, which will be a flying classroom and provide aerospace engineering students for over 20 UK universities to actually be flying and understanding the kind of engineering behind flying. So basically flight test experience. This Saab 340 will also be a vehicle literally for creating like new research and for research capabilities. So I just wanted to cite you on this because it means that Cranfield University and Cranfield Airport will be able to operate as a live sandbox when it comes to research, both into advanced air-to-air, but also air-to-ground management systems. Next, please. So what type of bilateral research projects are Saab looking for the UK-Sweden Aerospace Call 2020? The important question for this presentation. Well, this is a veritable smorgasbord of technologies that I'm going to talk about, and we're working quite a lot on several of them, but I just wanted to give you a bit of a taste for the type of projects we could be looking for. We are interested in projects on model-based software development of complex systems. As a system integrator, this is something we always are looking for. We're also interested in projects linked to the avionic systems. So that's the electronic system used on the aircraft, which includes communication, navigation, display, and management of the multiple systems. We're keen on projects linked to composite technology, so NDI technologies for faster evaluation, in situ consolidation of thermoplastic composite, welding of thermoplastic composites, etc. We are in general interested in projects around integration of RPAS in the ATM system. We would like to look at the teaming of manned and unmanned assets. In a civil perspective, this could, for example, be teaming between different rescue units, manned and unmanned assets in a sea rescue scenario. We do quite a lot of this already, but we're interested in pursuing more. We think unmanned remotely operated cargo is interesting. Large unmanned remotely operated cargo in the systems, the ATM system specifically. We are keen on projects connected to something called the U-space, which is also really about handling large numbers of drones in an efficient and secure way. Urban air mobility, but also collaborating on drone detection and counter UAS technologies. And of course, considering that we have our remote tower, we are also interested in developing that system, both the operations, but also to include more functionalities. So we welcome interest in that. Next, please. So I'm looking forward to talk to some of you at the one-to-one meetings later today. And again, I would like to thank everybody involved for pulling this session together and for being part of this really sterling collaboration opportunity. Thank you.
Thank you, Jenny. That was great. Okay, we're just going to hand over to Robert Lundberg from GKN. When you're ready.
Yeah, I'm now unmuted, I think.
You are.
Right? Yeah, you can all hear me. Great. So I've had some problems with joining this probably fantastic software that we do not use in GKN, but so I'm not able to see any slides myself, so I have to talk a little bit in the dark, but hopefully I will say the right things to the right slides. So I guess you got the first slide up now with my name on it.
We do, yeah.
Good. So I'm Robert Lundberg. Just like Gary, I'm normally in charge of European R&T programs, but doing a bit of national and in this case bilateral programs. I was also involved from the very start of setting up the very idea of these bilateral collaborations. So I'm really happy that we are now into the second call, and we hope to be more successful than we were in the first one. So moving to the next slide. Just one overall slide about GKN Aerospace as a group. I mean, you people in the UK, you probably know the aerostructures and the special technologies part of GKN, which is what is located in the UK. I mean, we are all in all quite a big tier 1 supplier and partner to the major OEMs, both on the airframe and on the engine side as well. And if you go to the next slide, the engine side is what Sweden is all about. So GKN Aerospace Sweden AB is the heading the engines division within GKN. I almost forgot our name before we were GKN, but I think we were called Volvo. This was sometime back in 2012. It's starting to be a number of years now. But we are now a proud division within GKN Aerospace. Looking at, if you switch to the next slide, which is a nice engine with some flags on it. Within the engines division, I would say around 90% is civil aerospace. But we should not forget the other two areas, which is military engines and space propulsion. So we actually provide the engine for the Gripen fighter aircraft, and we do some rocket stuff for the Ariane rocket as well. It's military and space is less than 10%, I think, of the turnover. So the main focus is on the civil side. And over the years, we have specialized in large, complex structural parts of engines, like turbine structures, low-pressure turbine cases, turbine mid-structures, diffuser cases, compressor structures, what Rolls-Royce calls intermediate compressor case, ICC, but also fan cases and fan frames. And part of the fan frame is the fan outlet guide vanes. So in addition to new parts manufacturing and being partner in engine development of new engines, we also have a newly started activity in Sweden, which is around repair, and especially fan blade repair. So repair technologies are also something that is of interest to us, that you will see a bit later on. I should also mention when I show this slide that I mean, the engine that you see is not just a sort of a marketing cartoon type engine, but it's actually a real engine model from our engine systems people, just to show that we also have the OEM capability in terms of assessing technologies at the full engine level, with whole engine models, with the performance models and so on. And this is also an area where we'd like to collaborate with the UK, where we see there's obviously a lot of good things in the UK, in places like Rolls-Royce and Cranefield, for example. So if we switch to the next slide, with a lot of small photographs of aircraft. So this strategy to be specialized in large engine structure has been fairly successful, so that today we are on board more than 90% of all new commercial large aircraft engines. And I think, in fact, we are the largest civil aerospace company in Sweden as well. Maybe not sure if I can say this with Saab people present, but well, I said it. Okay, so going to the next slide with a number of nice engines. These are some of the more recent and then more important engine programs that we have joined, and maybe of particular interest today is engine programs like Trent XWB with Rolls-Royce and Trent 1000 with Rolls-Royce, where in both these engines we are working with and responsible for the intermediate case, the intermediate compressor case. A very, very complex structure between the HP and IP compressors. Okay, next slide with the 3 examples of some technologies that we have developed within the company. So starting to the left, we were in fact one of the first companies introducing additive manufacturing in a flying application. That happened to be on the intercase of the Trent XWB. It's not a very large bit of this. This is quite a substantial part, but it's only a small bit of it that is added by additive manufacturing. But we learned a lot from that. The middle picture shows robotic laser welding, which is something we have developed and also introduced in service, particularly for turbine casings. And to the right, automated composite manufacturing technologies is something that we apply to fan cases and fan frames, and that we have already generated some business on the fan case side, and looking at finding more business on the whole fan static module, as we call it. Okay, switching to the next slide. Just listed a very rough list of topics that, I mean, if you take this together with the sort of component specialization that I showed, you can get a pretty good image of what we are interested in. So, I mean, obviously we are part of the Rolls-Royce supply chain, so we definitely want to try to find some good proposals together with Rolls-Royce. But we also have some suppliers to GKN in the UK of suppliers of new alloys, fiber preforms, forgings, castings, things like this. So there is also that side of the supply chain, which is very interesting for us to work with in the UK. I already mentioned that we are strong in additive manufacturing, basically on all the processes, powder bed or laser wire. So we are open for discussion on product ideas in this area. But it's not only additive manufacturing. I mean, we are ready to talk about any kind of advanced manufacturing technology, really, and things like automation, digitalization, non-destructive testing. I mean, of course, we are aware of the really great catapult centers that exist in the UK, and where we are looking for some collaborations there. And the final bullet that I also mentioned before is that we also want to look at, let's say, system level studies on innovative propulsion systems. And this could be, as Gary mentioned, he talked about more electric, new fuels. How does that influence the engine architecture, and particularly the kind of structures that we are specializing in? Will we see intercases with integrated electric generators or heat exchangers, or what is happening in the future? So regarding contacting me, I didn't manage to get the password to sign up for any meetings. I had real trouble with the software, but maybe if you contact Scott Pendry, he can forward your email, and I can set up meetings with our real engineering and technology experts to discuss any ideas or topics. I'm open for that for the future before the call closes. Okay, so just one final slide then. Just a few words about the COVID-19 situation. I'm not sure if you know, but within GKN Aerospace Sweden, we are now practice. I learned a new word in English. It's called furlough. I never heard that before, but this is apparently what we are having. So we are down to a 3-day working week at the moment, working Tuesdays to Thursdays, only 8 hours per day allowed. And this is going to be in place at least for the next 10 weeks. So have patience when you try to contact us. We might not answer your emails on a Monday or a Friday or an evening. And it will affect our ability to prepare proposals. So I'm actually in discussion with the Swedish funding agency if there could be a possibility to shift the deadline for the call even further into maybe into the autumn. It would help us a lot to get good proposals together. Okay, I think I had one final slide, which was just saying thank you for your attention and any questions.
That's great, Robert. Thank you. Unfortunately, we don't have time for questions, but if anybody wants to put it into the Q&A box, that's absolutely fine, and we can send that over to Robert and have that question answered for you. So we're just going to move on now to Tobias Bjornoff from Korban.
Hello everyone, I hope you all hear me. Tobias Bjornoff from Korban here. Thank you for the opportunity to present Korban. Who we are, what we do, and the areas and applications we would like to collaborate on. Yeah, next slide. So Korban is one of the fastest growing sustained tech companies in Sweden. Between 2016 to 2019, we grew from 5 to 96 employees. And our revenue grew about 5,822%. And even during the circumstances with COVID, we're still experiencing a growth rate of about 2.5 to 3 times at the moment. So we're very pleased with that and hope it will continue. Next slide, please. Oh, I'm back. So Korban is a deep tech technology, materials technology and manufacturing process solution company with applying our induction heating technology, which is basically what we focus on is induction heating of carbon fiber. And with applying it to different manufacturing processes all the way in the value chain from carbon fiber manufacturing all the way to recycling. We can save up to 95% of the energy. We can increase the throughput speed from 2 to 50 times, depending on what process it is. Obviously, it differs in between many different types of manufacturing processes. And while doing that, we can save up to 90% of the CO2 emissions. Next slide. Our induction heating technology works from room temperature up to 3,000 plus degrees Celsius. Basically, we are limited by materials, the fibers and the matrix, the binder matrix. The induction heating technology when heating carbon fiber reinforced products is uniform heating. It's ultra fast and volumetric, saying that we can in situ heat carbon fiber. We can heat the whole volume at once and we can control the heating. Our induction heating systems and hardware is designed in-house and built in-house, and it's now CE certified, UL, CUL, and CSA certified. I'll play a little video for you on how it works. It's just scratching the surface, but anyway. There's no sound.
I guess that's from them. They need to control it.
There's no sound. Okay, I see that there is no sound, but what we're saying here is that we can heat any scale object from really small, like a watch shape, up until an aircraft shape like a wing. We can control the flow patterns and the fiber volume. We can also get very good surface quality and very high yield in the process. Okay, next slide. So with our technology, what we've seen is that we can enable massive growth in the fiber reinforced products market. Our technology is best suited for high volume production, and we can increase the throughput up to 50 times in certain cases while slashing cost. As I said earlier, we are active all the way from carbon fiber manufacturing until recycling, while saving 95% of up to 95% of the energy, and also allowing for the larger volumes that the aerospace industry foresees for the future. Also with urban air mobility, as we slash costs, it's a viable option to use our manufacturing technology to cut the cost on B tools, etc. Also, as we're not limited to temperature, we would like to work a lot and are working a lot at the moment on CMCs, all the way up to 3000 degrees Celsius. And we have been working the last couple of years on pressure vessels, making it more efficient in production, as it's also a growth market where they need to increase the volumes a lot. Next slide. So I borrowed some of the slides from the Aerospace Congress just to show a little bit about the growth in the aerospace sector and why we think it needs to be a technology shift from today's manufacturing processes and heating cycles until changing to our induction heating technology, where we can support these kind of volumes that needs to be produced. Right, and then some of what we do at Corbon and what we would like to collaborate on in this call and bilateral with the UK and other Swedish partners. So efficient production of carbon fiber reinforced products using induction heating, obviously, something we do today, where we have, for instance, an RTM capacity where we can produce 2 million items in our new factory as of today, and we're planning to increase that up to 3 times during the course of the next year. Also, we can help with design and manufacturing, as we know quite a bit about lightweight structures and components. We're working a lot at the moment. We have several projects within induction welding and bonding of thermosets and thermoplastic composites. Also some aerospace projects at the moment. We are working on high temperature composite materials, CMCs, for instance, which obviously is of interest for jet engines. Yeah, our technology has, as we can reach really high fiber volumes and quality of the composite, we've been able to develop stiff and backlash-free ball joints, sliding bearings, kinematic pairs, where we today have developed a lot of robot applications, fixtures, which are mainly meant for assembling of cars, aircraft, and similar products. And I meant to show some fun videos here that we shot yesterday of us doing welding at above 1,600 degrees, but that will have to wait until you contact me because it was not updated with them. So thank you for letting us present again. And if you have any questions or would like to contact us on a collaboration, you can contact me on the previous slide. And also in the background is one of the lines we built for RTM in our new facility. Thank you very much.
That's great. Thank you, Tobias. Right, so moving on rapidly to the next session. This is the 2-minute pitch presentations. These are all people that are looking for potential partners to work with on this call. So they are 2 minutes, and obviously it's very challenging on the online, whereas ordinarily I'd probably you'd have all the visual cues and I'll be able to go up and probably drag you from the lectern. So I am going to time these 2-minute pitches. And I know you're aware that when the buzzer does go off, we will have to put you on mute and we'll move on to the next speaker. So first up is Stuart Olsen from Quintus Technologies, please. Hopefully you've managed to be unmuted. I haven't started timing, so don't worry.
Yeah, there we are. Thank you very much.
When you're ready.
Okay, I'm ready. Good afternoon. Stuart Olsen is my name. Represent the company Quintus Technologies.
Hello, Stu. Are you there?
Can you hear me?
Yes, I can hear you now.
Okay, should I start from the beginning then? Good afternoon, Stuart Olsen, representing company Quintus Technologies. We're a Swedish-based company. We've been in the industry for 50, 60 years, making industrial equipment. We make high pressure, generating and containing high pressure, and essentially for 2 different applications. One for densification of castings, commonly used in the aerospace industry. The same process is also used more for additive manufacturing and also for sheet metal forming. If you go to the second page, please. The product ID, we have looked into, and I present one of the areas here, only the metal forming area, but we're also interested in, of course, in additive manufacturing and that process, named hipping with other denominations as well, or hot isostatic processing. But for this call, we look at a process to form metal, and our aim has been primarily titanium 6-4. So the process we have used over the last 40, 50 years is a cold forming method, but now we have developed a process to extend the temperature up to 300 degrees and to combine it with an extremely high pressure force as well. We have built a full production capability in our facility in Sweden, and we can contribute with that. So we can do testing, we can do forming simulation, we can do tool design and tool manufacturing. And we seek a partner to validate the process. So essentially, Rolls-Royce, GKN, Airbus, Saab, companies who can validate and the process as such. So that's what we're looking for. Thank you.
Okay, thank you. Right on time. Nick Smith, please, from SHD Composite Materials.
Hi, hopefully you can hear me.
Yes.
Excellent. Right, okay. I say I'm Nick Smith from SHD Composite Materials. We're an independent UK manufacturer of composite materials, specifically prepregs, carbon fiber, glass, and natural fiber-based materials. We're a relatively small company based in Lincolnshire in the UK. We've got sites in the USA and Slovenia. So that's basically what we are. Next slide, please. I'll talk in more detail about the actual pitch. So we manufacture a large range of thermoset type prepregs. A lot of them going for aerospace, some automotive, and lots of other applications. The project I'm pitching here is a bio-based material, 100% bio-based, made from waste material. It's a resin. We can supply that in a prepreg form. It's got some really interesting properties. It's got extremely high temperature resistance. It's effectively non-combustible. And the aerospace markets for it are interiors, and also we gain some success using the engine components due to its really high temperature capabilities. It's also extremely good for electric vehicle battery boxes and items like that. What's innovative about it? It is a pretty unique material, not widely available in the overall market. We've been making it for a few years. We actually started on a NATEC program, harking back to an earlier presentation with ATI. We developed it on a NATEC program. And we can supply it in large quantities to support large aerospace programs. Services we can offer, we're a material manufacturer, so we produce the materials in volume. We have an in-house prototyping facilities, so we have an autoclave and we can actually make our own parts for prototyping and testing. We have a material test lab to support a program. Partners we're looking for, obviously aerospace is what we're talking about today, so anyone in the aerospace industry, and I'm running out of time. So there we go. Hopefully got most of that in. That was very stressful.
I'm so sorry. Okay, thank you, Nick. Right, next up is Oliver Naylord from Reaction Engines.
Hello, can you hear me?
We can indeed.
Brilliant. Well, firstly, thank you and congratulations for organising this event this afternoon. Given the circumstances, it's quite remarkable to get everyone here on the line. So my name is Oliver Naylord from Reaction Engines. We are a propulsion technology company based in Oxfordshire in the UK, and we're perhaps most well known for developing the Sabre engine. Sabre is an air-breathing rocket engine that will facilitate hypersonic high-speed flight in the atmosphere and also more efficient access into space. Without too much into the technicalities, it does this by combining the best bits of a rocket engine and a gas turbine engine. The key to Sabre, though, is very much its thermal management technology, and it allows us to capture, slow, and condition incoming air that comes at the engine very, very efficiently. And by conditioning, I mean that we're able to reduce the temperature of air from about 1,000 degrees Celsius to ambient conditions in less than a second. Next slide, please. On the next slide, you'll see our pre-cooler technology, which is really what I'm referring to when I talk about thermal management technology. And we actually demonstrated this at Mach 5 conditions late last year. So we've proven our thermal management technology works. So what we're doing now, in addition to pursuing Sabre as a hypersonic engine, we're also looking at how we can transfer our thermal management technology into other applications within the aerospace industry. So the technology is characterized by its lightweight, high effectiveness, its compact and conforming geometry, and also its thermal management performance. So it very much sits as a useful asset within the aerospace domain for vehicle thermal manufacture, engine thermal manufacture, and all that kind of stuff, really. So thank you very much.
Cool. Thank you. Time remaining as well. Great, thank you for that. Simon Peterson from EUREKA, please.
Yes, thank you. Can you hear me now?
Can, yep.
Yes. So Simon Peterson representing EUREKA, which is a software vendor within the product information, and we have a lot of knowledge and experience in product data technologies and related standards. Our main focus is sharing of product information across disciplines, enterprises, and keeping that information accurate and managed over time, also including changes. We are a Swedish company, 75 people distributed in UK, Finland, and France. As a company, we have a history of 25 years, and 20 of these years we have been a software vendor. We are offering a product, Aerospace, which is a standard-based collaboration hub for secure sharing of product information. We have some research background as well. We have participating in mainly the European Commission frame programs starting 2004 in projects like Vivace, Crescendo, Toike, with the main focus on collaborative modeling and simulation, supporting modeling and simulation across companies with partners such as Airbus, Rolls-Royce, Saab, and GKN. Next slide, please. If we look at our project ID here, it's mainly to combine structured information stored in databases and systems with semi-structured information stored in documents. And by enabling advanced digital capabilities on document-influenced business processes, using our technology together with cognitive services such as artificial intelligence and machine learning. Oh, it was really short.
Yes, it is, I'm afraid. Thank you.
But I think the information is in the slides and they will be shared, right?
They will indeed, yeah.
Yes.
Thank you very much.
Thank you.
Thank you. Max Burke from RISE IVF. I'll just change the slide when you're ready.
Hello?
Hello.
Do you hear me?
We can indeed. When you're ready.
Okay, so hello, my name is Mats Werke from RISE IVF in Gothenburg. And RISE is a short name for Research Institute Sweden. And we are working with applied research within manufacturing processes, automation, etc. And I have, together with colleagues in the UK, in Scotland, Advanced Forming Research Centre, developed an idea which we call electric driveline mass production for small aeroplanes. And as you can see on the picture here, there are different ways to design and produce electric engines. And each of those concepts sets a specific production line, and the production line sort of sets the costs, both the production costs and the material costs. So you can please change slide, please. So our project idea is to develop a cost-effective design and production concept for mass production of electric drivelines to small airplanes. And we have previously finished at RISE a project where we did a similar investigation concerning electric car production. And the innovation is to sort of convert this methodology and experience into new ideas for production technology for small airplanes engines. And we can offer experience and knowledge of from this project, and also from manufacturing processes and driveline systems. And we have together, both at RISE and AFRC, we have labs and test equipment for forming, heat treatment, stamping, and assembly of stators and rotor cores, etc. And we are searching here for end users, that small airplane manufacturers that may be interested in this, and also suppliers concerning, for instance, coil winding companies, etc. But we also have a wide network of companies and contacts that we can use for this type of projects.
Thank you.
Thank you.
That's great. Ben Pellegrini from Intelligence, please.
Oh. Hi, everyone. Hope you can hear me.
I can indeed, when you're ready.
Excellent. So my name is Ben Pellegrini. I'm co-founder at Intelligence, and we're a Cambridge University spin-out that is using a new type of machine learning to help guide the design and optimization of new materials, chemicals, and drugs. Our tools can handle very sparse and noisy data that is typical of very rare and expensive experimental data, enabling deeper insights, better decision making, and faster product development. Our technology has been validated with Rolls-Royce with the creation, validation, and patenting of a number of new superalloys for use in jet engines. We're also applying it to a number of other materials in welding consumables, battery components, and additive manufacturing. We're also currently part of the ATI Accelerator in the UK and exploring several new additive manufacturing materials with GKN and Boeing. Slide 2, please. We'd be interested in any projects that are focused on the design of any new materials, and these could be related to either improved physical characteristics in materials, perhaps reducing the cost of existing materials, or reducing the reliance on toxic elements or processes. Our approach can also reduce the number of physical experiments needed by around 80%. So any projects that might involve a number of expensive or iterative experiments would be of interest. And we're also looking at applying this technology or this approach of sparse data modeling to predictive maintenance problems where there is some limited real world data. And these could include things around corrosion modeling or fatigue modeling. Our unique capability is really the machine learning on sparse data, which is, as I said earlier, typical of the experimental data and common. And yeah, the rest of the information's on the slide.
Thank you very much. Thank you.
Cheers. Bye.
Next up is Jean-Marie Balagas at Perpetual Labs. Thank you.
Okay, can you hear me?
Yes, I can.
So good afternoon, everybody. My name is Gian-Maria. I am the CEO and co-founder of Perpetual Labs. Perpetual Labs is a young technology startup, and our mission is to develop the new generation of software solution for model-based engineering and Industry 4.0. We are currently one of the 9 startups that are supported by the Boeing ATI Accelerator, and we are based in London. So if we go to the next slide. So for this call, we are interested in 2 streams of research. On the one hand, we are interested in collaborating in a project that allows us to find an application for our virtual integration environment for the design of complex cyber physical systems. And what this means is that we are developing a virtual environment where you can create a high fidelity digital twin of complex engineering systems that are comprised of digital and physical components. And you can, this digital twin has end-to-end simulation, system simulation capabilities that are supported by our proprietary machine learning simulation technology. And what this virtual integration environment allows you to do is to manage requirements, manage, track, and validate requirements in a programmatic way. And the other streams of research that we are interested in is around a model-based framework for manufacturing process optimization and advanced product quality planning, because we have captured a requirement in the industry that there is not at the moment an environment where process planner can manage all the process design optimization and the quality planning in a coherent environment where they can manage all the metadata. And we are collaborating with Dr. Magnus Lundgren from KTH University on that. So essentially, if you are, the rest is on the slide, but if you are an OEM that is interested in model-based engineering, we would like to talk to you.
Thank you. That's great. Okay, next up is David Garrity from SES Defence.
Okay, thank you for the opportunity to speak here today. So David Garrity, I represent SES Defence, who are a UK-based technology and engineering company, primarily focused on supporting mission-critical communications, but also in the manufacture of electronics and cable harness systems in aerospace. More recently, we have developed our own IP and intelligent systems, which is the main reason I'm on the call today. So as you can see on the slide, we are mainly focused in those 4 market areas, but our primary focus has been defence and aerospace, as given by our accreditations there. We are an SME, approximately 70 million turnover, 150 people. We've been around for quite a long time, 70 years, but actually we've got a heritage on our Gosport site tracing back over 200 years. So quite well established. Next slide, please. So our project idea is basically to try and abstract one of two approaches we've used in other domains in this intelligent system area, but to aerospace hubs. And in terms of what's innovative about it, we've developed real-time prediction of specific events. For example, we developed a flashover warning wearable device for firefighters exploiting embedded machine learning. We've also developed a real-time retrofittable health classification system for marine diesel engines. So we believe that one of these two approaches actually has got a lot of read across into the aerospace domain. In terms of what we can offer, we've developed a lot of background IP and know-how in how to use machine learning approaches and how to develop into systems. We've also still got the actual background aerospace manufacturing know-how from the company heritage. And in terms of what we're looking for, we're really looking for an aerospace prime or tier one who's able to provide relevant data initially to actually try training these approaches and repurposing them, but also providing a potential route to a relevant environment trial. So demonstrating with hardware in the loop and actual real data on a real system. Okay, everything else you can see on the slides. Thank you.
Okay, great. Thank you. Time to spare. Right, so next up is Christian Olmertz from Finepart, Sweden.
Okay, can you hear me?
Yes, I can when you're ready.
Good, thank you very much. Glad to be able to speak here. Good afternoon. My name is Christian Olmertz and I am the technical manager and co-founder of Finepart. Finepart is a manufacturer of advanced water jet machine tools that takes water jet technology into the fine mechanics and high precision segment. We make a special type of machine tool that enables machining with many simultaneous axes, and that makes a possibility for cutting parts of high complexity. So we have been demonstrating that we can cut the parts down to about the 10 micron, plus minus 10 micron in tolerances, which is quite unique for water jet technology. Next slide, please. Our project idea is to see if we find an interest for cutting or rough cutting or like near net shape part cutting for hard materials. We think there's a potential for saving tool costs for ceramic inserts for hard materials, and we have the capability to cut to very small radii. What's innovative about it? It's the micro-abrasive water jets. They bring the benefits to abrasive water jet cutting to very fine tolerances. We build machines, but we also offer cutting services and research partners that are interested in looking into the possibility to cut advanced material, hard materials, or combination of materials using new cutting technology. So thank you very much.
That's great. Thank you very much. Next up is Volk Brunding from Cobham Gaisler.
Fine. Do you hear me?
We can, yes.
Yes. So I'm representing a company Cobham Gaisler in Sweden. We are located in Gothenburg, 40 people and slightly more than 10 million euros as a yearly turnover. And we are part, obviously, of the Cobham Group and organized within the advanced electronic solutions. And our main specialty is to develop state-of-the-art microprocessors, and including a software development environment. We base it on standard instruction sets, Spark, during 20 years, and we're now entering the RISC-V architecture. Fault tolerance, rad hard, high performance, low power, or I would say our success factors. And we are a market-leading supplier of microprocessors for all European satellite industry, which is our main business. We also have some sales outside space for AI, application, navigation, terminals. And we always work very close with customers and are used, I would say, to the space and aerospace domain. So next slide, please. So our ID is a certification of our RISC-V processor for use in aerospace equipment according to the standards. It's innovative, modern open standards. It's already certified and fault tolerant, rad hard, and we have full technological independence. Everything is made in Europe. We can offer the microprocessor IP, the software development environment, and the interaction with the foundries for the die manufacturing. And we are looking for either it can be large system integrators, as I heard Rolls-Royce needs software sensor fusion, cyber protection, Saab in avionics, but also with companies supplying computer equipment for aircraft systems and products. So yes, that was a short version. And happy to whoever wants to set up a bilateral talk, you have the contact details, so just send a mail or give a call. We will organize that.
Okay, thank you. Right, so next up is Fredrik Olofsson from Brogren Industries.
Hello, can you hear me?
Can, yes, when you're ready.
Okay, good afternoon. My name is Fredrik Olofsson and I'm R&D Manager at Brogren Industries. I've been at the company for about 10 years with different roles. Brogren Industries founded 1965, the same year Magnus, our chairman of the board, was born. His father Lars started his in garage and many small companies in Sweden was in the early 60s. Brogren Industries started as a traditional mechanical workshop focused on turning and milling from customers' drawings and needs. In 2010, we started our journey to qualify Brogren Industry as a supplier to aerospace industry, and I get the opportunity to work as a leader for the project. Mission from our owner and MD. We should be there, but how the hell are we doing that? It took about 2.5 years for us to get a lot of challenge to get the certificate AS 9100. Over the years, Brogren Industry developed a high-tech company working with milling, turning, TIG welding, laser beam welding, sheet metal forming, a lot of different processes. We have 3 business areas: aerospace, parts, and gas turbines. Brogren Industry would be in the position of the central role of the suppliers network and take care of complex structures with high quality requirements and technical challenges. We also take care of all kinds of qualification in 3 different levels: system level, method levels, and article level. Please change picture. Brogren Industries are working close to the customers' R&D, and we are involved in a lot of different projects at SME. Today, about 15 projects. We have contact and collaboration with many Swedish companies, university and institute. And I am a member of the board and also representative for Swedish SMEs in Aerospace Cluster Sweden, Camto, Chalmers Arena for additive manufacturing, metal, and so on.
Thank you.
Thank you.
Thank you. Okay, so next up is Timothy Figg from Aircraft Research Association.
Hello, can you hear me?
We've got a bit of feedback, but we'll see how that goes.
Okay. Good afternoon, everyone. Oh. Is that any better?
Yes, I think a little bit. Shall we go for it and see how we go?
Okay. So, Aircraft Research Association is a long-standing independent aerodynamic research company. We're located in Bedford, UK, and we were set up in the 1950s by a number of like-minded aerospace companies that wanted an independent wind tunnel facility. We've grown since then And we offer not only wind tunnel capabilities in the transonic range, but we also provide the design and manufacture of instrumented wind tunnel models, aerodynamic consultancy services, and linked to the testing, a range of novel, innovative optical testing techniques. Our job in the industry is to provide a key link in the concept development phase of a new commercial or military platform. And our output is high fidelity data to allow our customers to optimize aerodynamic performance, the reduction of drag, noise, fuel burn, etc. Next slide. Our idea is to industrialize some testing techniques we have, and that provides our customers with high volumes of additional data, which is valuable. And the partners we are seeking are aerospace clients, such as engine manufacturers, airframers, etc. I believe that's my 2 minutes, and I'm happy to take any questions offline.
Okay, thank you very much for that. Next up is Joe Summers from Airborne UK.
Good afternoon, everybody. My name is Joe Summers. I'm Managing Director of Airborne UK. We're a subsidiary of Airborne in the Netherlands, who employ 125 people and are involved in automation and manufacturing of advanced composite structures. In the UK, we're an SME and employ 20 people. We have capability around conceptual design of composite structures, building of tooling, fixtures and prototyping of same structures, but also the industrialization to high rate using the automation technology of the group. Next slide, please. We have a couple of ideas. One is evolution and improvement of our existing automation solutions. You can see below honeycomb potting, ply kitting, a tape laying or automated laminating cell, and a high volume thermoplastics production line. We also look to develop digital technologies to produce digital twins of the same automation equipment, and have ideas around developing web portals and remote access to automation equipment to create so-called dark factories, particularly appropriate in times when it's difficult to put people into your factory. We believe composites is an interesting topic for the aerospace industry. We're looking for partners in either aerospace OEMs, tier 1s or tier 2s, interested in industrialization of composites to talk to us further. Thank you.
Okay, great. With time left over as well. Thank you very much. Okay, next up is Bogdan Renholm from Debo Production Partner.
Yes, can you hear me?
Yes, we can hear you when you're ready.
Oh, hello. Yeah, my name is Bogdan Renholm. I work as a technical sales production engineer at Debo. We are manufacturing advanced CNC parts. We're a small company. Next slide, please. We are a fine mechanic company that's manufacturing complex details in such materials as aluminium, brass, steel, titanium, Inconel, or whatever. We like to manufacturing difficult parts in advanced CNC machining. In offering we can milling, turning, cutting. And we also have the certification called the AS 9100D. And we want some more contacts in the aerospace. Thank you for that. Thank you.
Okay, all right. Thank you very much for that. Well in time. So we do have 5 more pitches to go through, but I'm just looking at the time, and apologies for slightly running over. I'm just conscious that some of you have got one-to-one meetings from 3:15. If you do, then feel free to leave the meeting. You will get a copy of all the slides. Please accept our apologies, and we'll just give the ideal opportunity really to let you have a couple of minutes break before your first meeting. So if that's the case, then thank you for joining us and goodbye. But next up, we've got Nico of Delidis from Cranfield University, and I do apologise if I've pronounced that incorrectly.
Yes, hello, can you hear me?
We can indeed, yes.
Okay. I'm actually looking at different slides, so I'm not sure if those are my slides. Yep, here it is. So hello, my name is Nico Abdelidis, and I'm representing the Autonomous and Cyber-Physical Systems Center at Cranfield University, presenting an idea that deals with advanced diagnostics using ground and aerial robotics in order to improve times and efficiency of aircraft inspection and monitoring. So if we move to the next slide, please. So here you can see a visual image of the actual concept, which is a UAV equipped with an infrared thermographic NDT system, something that we have been developing in Cranfield. Will fly around the aircraft structure that can be either a metallic or a composite structure in order to inspect it and locate different kind of problematic areas. Basically, this is a prompt and real-time monitoring approach that could identify defected areas within the structure, and from there, a ground robotic system, which is equipped with a phased array ultrasonic system, will go and assess the defected zone in order to accurately evaluate the actual defect. All the collected images from both of these NDT techniques will provide the foundation for building a database for future machine learning to automatically and increasingly accurately identify the defects. This could make it possible to make credible fly, no-fly decisions quickly and provide maintenance services with valuable information. In other words, develop advanced diagnostic and monitoring of aircraft structures and basically contribute in the digital MRO area. So we're looking basically for companies of any size that work in the areas of AI, robotics, or NDT diagnostics. Thank you very much.
Okay, thank you very much. Right, so next up is Dag Asvan from Spacemetric.
Can you hear me?
Yes, we can hear you.
Oh, splendid. So good afternoon. My name is Dag Asvan again, Operations Manager at Spacemetric. We specialize in image data management, helping customers to get the right data to the right people at the right time. And our Keystone software uses rigorous photogrammetry to attain the highest possible quality analysis-ready data. And our aim with this UK-Sweden call is to improve image handling capabilities of aerial platforms to optimize data downloads. I'll come back to that next picture. Keystone initially only, Keystone initially only deals with the metadata, dealing with images only when needed, and then on the fly, just in time, if you like. This saves time and effort. So in the value chain, we provide image data management, as you can see in the picture there, between sensors and image interpretation. In a way, we are plumbers, making sure that the right stuff gets to the right people. Some clients are satellite operators. We provide the full image processing chain from sensor design to data presentation for both still imagery and video. And one airborne solution is the image handling system for the Swedish Armed Forces Saab Gripen, which you can see in the picture, and Keystone contributes its speed to the Intel process there. We're based in Stockholm with a UK office. We're 10 strong. Next, please. So our thinking for this call is to develop our existing ability to use UAV data, avoiding bottlenecks through optimized data handling. Our patented bluestone technology enables us to, from the ground and even with a very low bandwidth, to rapidly understand what data is available on board an airborne asset. We can then select priority data for priority download. So now we'd like to connect this capability to innovative UAVs, innovative sensors, innovative compression methods, that's comms basically. And we would be very happy to discuss the possibilities of cooperation along these lines with you, ladies and gentlemen. Thank you for your attention.
Thank you very much. Okay, next up is Dragos Dancila from Percy Rock.
Hello.
Hello.
Okay, great. Thanks for the opportunity. My name is Dragos Dancila. I'm the CEO of Percy Rock. I'm also associate professor at Uppsala University in Sweden. Percy Rock is a spin-off from the university. It was founded at the intersection of machine learning and solid-state amplifiers. And together we want to revolutionize the curing of composites and provide better efficiency and lower lead times. So we are providing the technology for precision manufacturing involving heating processes based on microwave power, and that we apply to carbon fiber composite manufacturing. So next slide, please. So there are the current status that carbon fiber composites are using large autoclave to be cured, and this is energy inefficient, so the whole oven needs to be heated. While using microwaves, then only the composites will be cured. So we will provide a very high reduction in the energy needed for curing with microwave. So what's innovative with our solutions is that we bring in machine learning to the microwave platform. So we have continuous feedback and control while we are doing the processing. And this goes in line with the development of the Industry 4.0, where the solutions being developed have controlled and are continuously optimized. So what we can offer is then the development of the solution involving software and hardware, antennas and amplifiers towards curing with microwaves.
Thank you.
That's it. Thank you.
Great. So next up is Ian Cornwall from Kraken IM.
Everyone, can you hear me?
Yes, we can hear you.
So my name's Ian Cornwall. I work for, I'm a co-founder of a company called Kraken IM. We're a UK-based tech startup. I'm pretty sure my contact details should be on this slide, but they appear to be missing. We're another one of the ATI Boeing Accelerator cohort teams, and we're specifically interested in engineering data from supply chains, and we use blockchain to track the provenance of information that comes from supply chains. Next slide, please. Okay. So we're specifically interested in extending our platform to, we've recently implemented smart legal contracts, which is basically a way of tying computational elements to a paper contract. So we're interested in applications that we can use smart legal contracts for. Potential use cases include supply of data from supply chains or maintenance of equipment, or automated factories, which is very relevant under the current climate. We're a tech startup, so we're specifically interested in people who have supply chains, particularly distressed supply chains in the current climate, because we think this is an opportunity to change. And we can offer a software platform that can both define engineering requirements, approve their delivery, and then tie that to a contractual deliverable. So smart legal contracts are the second generation of smart contract. And basically it's a way of tying the legal contract to a piece of paper. So anyone who has supply chain agreements, contracts, and engineering data that they need to get from supply chains, we'd like to talk to you, please. Thank you.
That's great. Thank you very much. And the final presentation is from Billy Josephson from LFB.
Thank you for your patience. LFV, we are a navigation service provider, but we also have a research and innovation departments where we support. Our main business is to keep the skies open and provide a safe and fair and efficient use of the airspace, but also enabling new actors, entrants like UAVs and so on, and space to ground operations, access to the airspace in an efficient way. We are heavily linked to Linköping University in the research area, where we address areas like AI, machine learning, optimization of various processes, but recently, the last 4 or 5 years, UTM and UAM, which is an increasing area. So we see that things are coming together. I mean, the integration with various transport modes and airports. And so that's why it's so important to link up with all of you. The next slide, please. Yes, so we are open for project ideas within urban air mobility, optimization, remote tower that was mentioned, the remote control processes, risk and safety assessment and development based on requirement from new technology, information visualization. We like also to address the whole thing from the airport and outside the airport. And I claim we have novel approaches for basically these points together with the Linköping University competencies. And yeah, we have a testing and simulator environment we could use also. And we seek, partners within service provision, city planners, industry and academic, and so on. Hopefully 1 + 1 could be 3. And hope for a successful match and then a good collaboration. Thank you.
That's great. Well, thank you very much to Billy, and thank you to all our speakers actually, and particularly those of you that kindly submitted a pitch presentation. It was all very, very interesting. Apologies we've run over, but let's just get things finished off for you. And I'm just going to hand over to Anders Blom from Innovair, please. Hopefully you should be unmuted.
Yes, am I now?
Yes, we can hear you.
Excellent. So thank you so much, Natasha. And realizing that we are late, I shall be fairly brief. But I would like to start with thanking the Aerospace Technology Institute for building up very good both professional and personal contacts with us here in Sweden. And for this particular call, I also like to thank all our colleagues from Innovate UK and Vinnova for helping us at ATI and Innovair making this call to actually take place. Then, of course, I would like to thank all the speakers of today, both for keeping the time schedule, which was quite intense, and for presenting some very interesting technical content. I think we may look forward to very interesting proposals in this bid. We do hope for oversubscription to the call, and one very good reason for this is that this call needs to be full in order for us to argument for future calls together with hopefully even larger financial level. I think it's very interesting for us in these very difficult times to continue to do research and innovation in aeronautics. And I also believe that we need to do so in order for everybody in our innovation system to materialize as winners in the new post-corona world when aeronautics will take off again. So I will not bother you anymore, but I wish you all success in the call and continued good health. So thank you very much and bye-bye.